All signs point to CES in January 6 not only showing us the RTX 50 series for the first time, but also the era of neural rendering of video games. More on that and where am I getting this demonstration of it in just a minute. But we have a bunch of other news to talk about today, including Acer accidentally listing a 5090 and 5080 equipped gaming PC ahead of time, confirming only 16 gigabytes of VRAM on the RTX 5080, although it's GDDR7 and how fast. We have some leaks discussing that, as well as we have Nvidia saying they are investigating the reduced performance by using their Nvidia App, and there's some hardware unbox testing discussing exactly what in the app is causing the issues and confirming those issues. We also have some exciting leaks regarding Strix Halo. This is an amazing looking APU from AMD. And then we also have apparently Intel's B570, which if you're excited about the B580 with 12 gigabytes, hey, 10 gigabytes on the B570, apparently review samples already out to at least one review outlet for that B570. We also have a little bit more gaming information towards the end, a whole bunch more about neural rendering in just a second, but first, unfortunately I have to admit that I've been spreading misinformation in the comment section, or at least information I spread is now out of date. Mr. Daniel, do you sleep? No, has been upgraded to yes, because I am now proudly pro nap. Honestly, guys, I moved closer to my job teaching because I also do that on top of running the YouTube channel full-time. People are like, how are you doing this? Power naps in the afternoon are now possible. I get home from work quick, get in a power nap before my kids get home, and it's been amazing. Now, in the past, I couldn't nap. I am now completely blacked out, cannot see a bit of light, and also I can kick on some white noise right here with completely flat Bluetooth speakers, which is amazing because I'm a side sleeper, and headphones in the past have been incredibly painful, making it difficult for me to nap. This is also really nice when I go to sleep at night. A lot of times I like to put on like an audiobook or a podcast, and I can't tell where any of you are. This is completely blacked out. Anyway, I'm gonna take that back off. But the point is that this has completely revolutionized both my actual sleep at night as well as my ability to actually get in some afternoon naps, which is really amazing. Really, it has made me so much more alert and productive. There is a wide variety available. Again, this is the sound version, which I think is really cool, but they also have the Pro version. They have the Silk Mask, Manta Weighted Mask. We've got a cool mask, a steam mask, the original Manta Sleep mask, and a huge thank you to Manta Sleep for sponsoring today's video and allowing me to be proudly pro nap. And if you check out the link in the video description, you can get some amazing deals right now on holiday gifts. There's a 15% off site-wide sale, plus a free mystery sleep kit. For those who missed the Cyber Weekend, this is the perfect opportunity to grab a great deal on sleep accessories for yourself or gifts. Can't emphasize this enough. These make amazing gifts. And again, a mystery sleep kit included with the 15% off site-wide sale if you click the link in the video description. So what do I mean about neural rendering of video games? Where am I getting this footage? And why do I think this is very likely to be a big topic at CES with the 50 series? Well, let's dive into my journey down this pathway today. First of all, Hardware Lux has an article, this is translated from German, talking about Inno3D's announcement for what they will be covering at CES. Now, within that post, if you actually follow up the actual Inno3D post, they talk about their coolers and whatnot, but then we get this. This is where we get into neural rendering. There's a lot going on here. One of them is specifically neural rendering capabilities, revolutionizing how graphics are processed and displayed. So that is one of the highlights for Inno3D's CES presentation talking about their products related to GPUs. Now, it's very likely that board partners that work closely with Nvidia are fully aware of what Nvidia's big CES talking points are going to be and have presentations to follow up and expand on how their products relate to these. So there's the neural rendering capabilities being referenced right here. Along with this, we also have discussion of advanced DLSS technology. Now, it's possible that they're just talking about DLSS technology that already exists and the fact that it is advanced. It's also possible that this is referring to a further advancement of DLSS technology, although it's still just discussing even better image quality and higher frame rates. So potentially this is expansion of what's kind of already out there, but it doesn't sound like an entirely new thing that is like somehow different than the DLSS that we already have at a fundamental level. They also talk about enhanced ray tracing, improved RT cores, AI accelerated graphics. Now, this is talking about improved performance in AI assisted tasks and better integration of AI in gaming and content creation workloads. Okay, but then we get into that neural rendering capabilities, revolutionizing how graphics are processed and displayed. They're talking about AI enhanced power efficiency, whether that's something that Inno3D is doing themselves or that'll be a wider scale thing for the 50 series in general is unknown at this point. Then we have improved AI-driven upscaling. However, this is talking about beyond gaming. So this is more for content creators. And then they also have generative AI acceleration. So at this point, the biggest one here that stands out as something that is potentially new is neural rendering capabilities. So I know that, first of all, that rung a bell talking about some NVIDIA white papers that I've reported on in the past from SIGGRAPH presentations. So we've already talked about neural texture compression in previous videos. At SIGGRAPH 2023, NVIDIA presented research on the neural compression of materials. However, I went in to see if they had any newer presentations related to neural rendering at the 2024 SIGGRAPH. And they do. We have real-time neural appearance models, and that's the video that I was showing you here. This is from their materials available for the 2024 SIGGRAPH presentation on neural materials. You can see the diagonal bar across the screen here, where this is the ground truth reference model in the bottom right corner, and the top left corner is the neural material pathway. Now, this just switched to the 2x32 neurons, which is less accurate than the 2x64 that we saw initially. But you can see that even at this level, there's quite a lot of accuracy here. Also, it's important to point out that this does not mean, I'm sure you guys have seen videos talking about entirely AI-generated games, where you're literally playing a game that is basically being hallucinated by an AI. And that is not what I think we're going to be getting from NVIDIA when we look at neural rendering capabilities. I think it's more along the lines of these neural compressions that we've seen in previous videos, as well as potentially this neural appearance models. So what is going on here? I have fully read the available information here, and to be honest, a lot of this is rather in-depth regarding the actual implementation of how this works. The abstracts themselves provide a bit more of a kind of summary of what is going on here that perhaps we can delve into a bit. So again, the big neural rendering stuff that I could find research on is these neural materials, neural appearance models, and then neural compression. So neural compression of material textures seems a little simpler to wrap your head around. The idea here, and I've shown this in videos, back after the 2023 SIGGRAPH, is that the textures on the left here are neural textures. On the right is BCX textures. That's a more traditional method of doing this. And you can see that these are similar texture size at 3.6, like storage size, 3.6 megabytes on the left versus 3.33 on the right. However, I play the video, you can see as it scans through here, on the left, you have massively more detail at just a slightly larger file size. That's cool. However, there's a major downside to this, which is the 1.15 milliseconds to do this on an RTX 4090 GPU at native 4K, whereas this one was 0.49 milliseconds. In the video, if you listen to it, they describe, rounding off as about 1 millisecond of overhead. Now, a millisecond doesn't sound like a lot, but in terms of if you're rendering frames at a high frame rate, every millisecond counts. However, they also describe in this process that if you're rendering a larger scene, including using like ray tracing and path tracing, there's the compute time that's happening for those other processes. So during that, the rest of the computation of the frame, this extra 1 millisecond can kind of be hidden by happening in parallel to those, if I'm understanding it correctly. Meaning it might not actually slow you down a millisecond for your frame times because other things would be taking at least a millisecond as well, and this could kind of be computed at the same time as some other things like the ray tracing, for example. That's at least how I understand this. To be clear, I am not I'm a little out of my depth reading papers like this. Like I have a math degree, but not specifically in like computer graphics and this style of stuff. Anyway, so that's that. So the abstract for neural textures, neural compression of textures, is the continuous advancement of photorealism in rendering is accompanied by a growth in texture data and consequently increasing storage and memory demands. So the idea here is to have higher resolutions without increasing storage and memory demands. So to address this issue, we propose a novel neural compression technique specifically designed for material textures. We unlock 2 more levels of detail, i.e. 16 times more texels using low bitrate compression with image quality that is better than advanced image compression techniques such as AVIF and JPEG XL. At the same time, our method allows on-demand, real-time decompression with random access, similar to block texture compression on GPUs, enabling compression on disk and memory. The key idea behind our approach is compressing multiple material textures and their mip-map chains together and using a small neural network that is optimized for each material to decompress them. Finally, we use a custom training implementation to achieve practical compression speeds whose performance surpasses that of general frameworks like PyTorch and by an order of magnitude. So that's the general idea. All my sources will be linked in the video description, so those of you more technically minded could dive into some of the additional details about that. Now, again, that's from 2023. So not only is it given more time to potentially get this into at least one video game, potentially, there's also, like I said, this update for 2024, I've seen real-time neural appearance models. So this seems a bit more advanced. So this is where I was showing you that diagonal side-by-side at the beginning here. This is the neural material idea. So let's go ahead and read at least the abstract of what's going on here. So they're saying we present a complete system for real-time rendering of scenes with complex appearance previously reserved for offline use, meaning you couldn't do this in like real-time rendering. This is achieved with a combination of algorithmic and system-level innovations. Our appearance model utilizes learned hierarchical textures that are interpreted using neural decoders, which produce reflectance values and importance sample directions. To best utilize the modeling capacity of the decoders, we equip the decoders with 2 graphics priors. The first prior, transformation of directions into learned shading frames, facilitates accurate reconstruction of mesoscale effects. The second prior, a microfacet sampling distribution, allows the neural decoder to perform importance sampling efficiently. The resulting appearance model supports I don't know how to pronounce this word, guys, anisotropic sampling. I know I see it in graphic settings menus, but I don't always, I'm not confident how to pronounce it anyway. And level of detail rendering, and allows baking deeply layered material graphs into a compact, unified neural representation. By exposing hardware-accelerated tensor operations to ray tracing shaders, we show that it is possible to inline and execute the neural decoders efficiently inside a real-time path tracer. We analyze scalability with increasing number of neural materials and propose to improve performance using code optimized for coherent and divergent execution. Our neural material shaders can be over an order of magnitude faster than non-neural layered materials. This opens up the door for using film quality visuals in real-time applications such as games and live previews. So this, if a lot of this your eyes were glazing over, I think in the end you're like, okay, so what is the point of any of that? What am I supposed to take away? So the idea here is that the neural material shaders can be, not is always, right, over an order of magnitude, that's a lot, faster than non-neural layered materials. And that this would open the door for using film quality visuals in real-time applications such as games and live previews. Okay, so that's that. Now, the idea here, again, they talk about the neural BRDF model. I don't think we need to try to make sense out of this diagram because you guys are probably not the ones programming this stuff. But here's kind of the idea here. So if we look at this diagram, we see a scene with 4 materials that we approximate using the proposed neural BRDF. The first 3 columns correspond to different configurations of the BRDF decoder from fastest to the most accurate. So it's fastest on the left, getting more accurate, right, from going from 16 neurons to 32 neurons to 64 neurons, but this time also going up to 3 layers instead of 2 layers on the first 2. Then they have the ground truth reference on the right-hand side. Then they have flip error images in the corners. Timings quantify the cost of rendering a 1 SPP image of the scene. We show images with 8,192 samples to suppress path tracing noise. Okay, so in other words, what does it mean about the flip image? So you guys see in the corners here, it might be a little hard to see in this video. By the way, if you're watching on a phone, you can pinch to zoom on the YouTube app. Anyway, you can see that, so this is basically like a map where the more stuff is showing up here, I think is being showing up as error when compared to the ground truth image. So you can see that the faster ones have more error and there's less error showing up on the more accurate ones. You can see the cost in milliseconds of rendering time. So here we have 3.15 milliseconds, and then you get a lot more accuracy, or in other words, a lot less error, going up to 32 neurons and only going up to 3.71 milliseconds compared to 3.15. But then jumping up to 64 neurons with 3 layers increases all the way up to 6.31 milliseconds. However, their ground truth reference was a total of 13.25 milliseconds. So all of that sounds like a lot of milliseconds to me. So then the idea is, so how are you able to get this running, fast enough for a video game or live preview, which is what they mentioned. So again, if we go back to the abstract where a lot of this might not have made sense, the idea is of how they're getting it running is talked about right here. So by exposing hardware-accelerated tensor operations to ray tracing shaders, we show that it is possible to inline and execute the neural decoders efficiently inside a real-time path tracer. So again, while a lot of this is also over my head, so you're not the only one a little confused here, as I'm trying to read that, what I'm kind of hearing is that this can happen. So if you're doing this inside of a path tracing situation, again, the path tracing takes time to compute as well. So in other words, you wouldn't necessarily, by running it inline, right, to show that it is possible to inline and execute the neural decoders efficiently inside the real-time path tracer, I'm reading that as you don't add these frame time costs to the rest of the frame just as a sum, right? If some of this is happening in line, I think that means like at the same time. So the path tracing itself has a frame time cost, and perhaps, and this has a frame time cost, but the cost of doing both together isn't necessarily their sum if it's happening at the same time and not necessarily competing for the same resources on the GPU, if that makes any sense. So, in other words, whether or not this is actually what Inno3D is referencing on their CES presentation here, this is definitely research that NVIDIA is doing. So, I don't know if this is coming to games in 2025, but I have a feeling we are going to see discussion of these types of neural rendering techniques at CES 2025, and that's why it's showing up here as neural rendering capabilities revolutionizing how graphics are processed and displayed on this post here. Okay, now let's go ahead and move along to some additional leaks. So videocards.com caught Acer posting their Predator Origin 7000 series gaming PCs with their 5090 and 5080 listed. So if there was any doubt now that the 5090 would have 32 gigabytes of GDDR7 memory, Acer should have now just completely removed any doubt. Also, if there was any doubt that the 5080 would have only 16 gigabytes of VRAM and it is GDDR7, again, Acer has removed any doubt. So it's basically, I would consider it pretty much 100% confirmation. Maybe we'll call it 99%. I guess Acer could have just put up some placeholder text here, but that doesn't seem like what this is, right? They're getting their products ready to unveil for CES. It's on their website, goodjobvideocards.com, for catching them. All the sources will be in the video description. So a 5080 with 16 gigabytes. What do you guys think about that? Like, I've seen a lot of comments on my channel pretty upset about the idea of a 5080 with 16 gigabytes. Personally, I'm more upset that the 4070 is rumored to have 12 and that the 4060 is rumored to have 8. Because 8 is definitely a problem for rendering maximum texture settings in a lot of games right now today, and 12 is fairly borderline, and there are some examples of games spilling over that now. 16 gigabytes, on the other hand, in realistic gaming situations that don't involve a whole bunch of modding and or other crazy stuff, I haven't seen 16 gigabytes being an issue. However, a 5080 is a very powerful graphics card that could theoretically be used many years into the future. In which case, I could see it still being a viable GPU when we get, the next generation of consoles even. At which case, if those consoles come with an increased, RAM capacity compared to current gen, it's like VRAM usage tends to go up over time, and 16 gigabytes is still quite a bit. It's not immediately presenting massive concerns to me. However, the longevity of a card this powerful being potentially impacted by having 16 rather than something like 24 or 32 is a bit frustrating, especially when you throw price into this, right? Because if the 5080 is at least $1,000, or maybe even even $1,200, $1,300. Maybe we don't know the price, right? But depending on the price, it starts to feel like they're penny pinching, because could you just do a clamshell design and get 32 gigabytes on here for the sake of, longevity and just, okay, if you're spending over $1,000 here, how much more does 16 gigabytes of VRAM cost in the grand scheme of things? Like, it feels like it could be on there if NVIDIA wanted it to be, right? But they don't want it to be, and this is confirmation that the 5080 only has 16. It is GDDR7 though, and how fast is it? Well, this is, I would say, a less solid leak. But this leak is pointing to 30 gigabytes per second. Sorry, not gigabytes, gigabits per second. There's a difference there, times 8, big difference, okay. And this is again coming from videocards.com, but they're getting the information sourced from BenchLife. The translation is, according to our sources, that being BenchLife sources, at this stage, in addition to the GeForce RTX 5080 using 30 gigabit per second DDR7 memory, models including the GeForce RTX 5060 series are also configured with 28 gigabit per second GDDR7 memory. So now videocards.com has this helpful table kind of summarizing the information we've had leaked so far regarding these GPUs and their memory speeds and just other specs that we've had leaked previously. So it's really starting to look like this is where we're at with things. Again, my biggest issue with VRAM is here on that 5070. This 5070 Ti could potentially be interesting if it's at the right price, but if it's super expensive, that'll put a damper on that. And the 5090 does look like an absolute monster, especially compared to the rest of the product stack, since the 5080 looks to be like half of it. Now, does that mean it's half as fast, especially if it has slightly faster memory speed compared to the 5090? You know, we'll have to see what actually bears out in actual gaming performance. Now, in yesterday's video, I discussed the fact that there were reports that Nvidia's new app was reducing gaming performance, and there were charts available testing this from Tom's Hardware. However, as I mentioned in that video, they had the app open, but they didn't try out like which specific settings in the app, or what if the app's closed, what if you turn off overlays, all of that kind of stuff. Since then, we've had a couple of things. One is we've had NVIDIA themselves state that they are aware of a reported performance issue related to game filters and are actively looking into it. You can turn off game filters from the NVIDIA app settings, features, overlay, game filters, and photo mode, and then relaunch your game. And we've also had Hardware Unboxed do a video testing this out. And again, they have confirmed that it's not the entire app that's causing issues. It appears to just be the photo and filters needing to be set to off. In some games like Cyberpunk, there's a small but measurable performance difference. In some other games, the performance differential is much, much higher. For example, in Hogwarts Legacy, you can see a much more significant performance differential with the filters turned on. Anyway. So that confirms this, and again, the performance hit changes based on the game. You could look at Hardware Unboxed video, which will be linked in the video description if you want to see all of their testing. Basically, what you should take away from this is if you have the NVIDIA app installed, you should probably turn off photos mode / filters unless you're specifically using that feature at that time. You also require a full game restart in order for the performance to go back to normal. Now, we've seen a benchmark leak for AMD Ryzen Max Plus 395 Strix Halo. Now, this is interesting because Strix Halo is supposed to be a ridiculously massive APU when it comes to the GPU inside of it. It's looking like a 40 compute unit GPU according to the leaks, which means you could have some significant gaming performance on an integrated graphics-based laptop, mini PC, that kind of thing. Now, it's looking like Asus will be launching a laptop with this chip, and it's looking like we have seen this ROG Flow Z13 show up on a benchmark here. So if we take a look at this benchmark, we get single core and multi-core performance. In other words, it's a CPU benchmark. Oh no, I wanted to see what the GPU could do. However, that being said, it does have some confirmation of the part here. We can see the AMD Ryzen AI Max Plus 395 with Radeon 8060S. Look at that. Radeon 8060S is apparently what they're calling the GPU in this thing, which is a new naming scheme. Is the low end of the 8000 series integrated graphics? Interesting thing to look at there. But then again, we are also seeing the CPU that's inside of this is a 16-core CPU. Anyway, so we can see some of the specs there and all of that, and the overall benchmark result is a good result for the CPU. Apparently coming out significantly faster than a 7945HX, which scores 2,736 single core and 15,896 multi-core in the same Geekbench test, which is interesting. But anyway, and it also looks like it beats the 3D V-Cache version of the part, which scores 16,393. So it looks like the CPU is going to be very effective, but then also, again, I'm really interested what this GPU is going to be able to do with 40 compute units. That is absolutely massive compared to what we've seen in previous mobile chips. We've seen 16 compute units as kind of the top end there so far. Now, a lot of times integrated graphics seem constrained by system memory, so I don't know, I'm just curious how that ends up all playing out. Also, the Intel Arc B570 has apparently shipped out review units to at least one reviewer, this being Andreas Schieling, saying, what have we got here? The Intel Graphics Arc B570 from ASRock arrived earlier than expected. Now again, that doesn't mean that the benchmarks will be allowed to be posted anytime soon, but maybe it's indicating that Intel could be thinking about getting this information ahead of any big competitor announcements at CES. So maybe, despite the card's release date being a while out, maybe they're trying to get information out there sooner than the Nvidia new GPU announcements. Now, I've tested out Indiana Jones and the Great Circle on this channel. I want to mention that Update 2 is out, bringing support for GPUs that have less than 8 gigabytes of VRAM, because previously they were unsupported. This game is very VRAM hungry, but apparently a little bit less so now with less than 8 gigabytes of VRAM. And global illumination improvements to the console versions. If you actually read the full system patch notes, you get PC-specific fixes, including solving some DLSS-related issues. Specifically, also, NVIDIA frame generation had issues with HDR support. And there's still a known issue that NVIDIA frame generation may be temporarily disabled if HDR is activated for the first time. To work around this issue, you would disable and then re-enable DLSS, and that only needs to be done once, and then that should be solved. There's some other issues kind of solved here as well. And they also fixed an issue where global illumination may be completely disabled when playing with below minimum VRAM graphics cards. So previously, if you had below 8 gigabytes of VRAM, the global illumination would just be disabled, so you wouldn't get any real lighting, since all the lighting in the game was based on the ray tracing. Last thing I want to mention is that the Witcher 4 devs have confirmed Gwent. So if you're concerned that the new Gwent expansion might not actually have Gwent, they have confirmed Gwent. So there's that. I hope you guys enjoyed today's video, and I hope that you have an excellent day. That's what I was thinking. Don't know why I struggled to say it. Hope all of you have an excellent day.